Okay, cool. Well, today I'm going to be presenting about how to download and how to analyze Twitter data. And also I might get into how to download and analyze Facebook data from Crowdtangle. I'm mostly going to be talking about Twitter data and the Twitter API. I sent you guys like an email last week if you're interested in following along. You have to get API credentials from Twitter. I sent you some instructions on how to do that. You don't have to do that though. I will also cover like how to get API credentials, like the whole process of doing this. And if you want to follow along, I made a GitHub that has some code for you. So I think I'm going to share that on the lab Zoom. So let's see. Let's see how I share a link while I'm sharing screen. Maybe I should briefly stop sharing, and here is the GitHub page. If you want to look at that, I'm going to start sharing again. There we go. Okay. So this GitHub page essentially has some code and some data files that I put together recently that I will be going through. So if you want to follow along, you don't have to. You could also just like watch and then follow along later. The best way to do this would be to go to this GitHub page and then download the code using this little green arrow right here. This is code. And you can download a zip right here. So we'll download the zip file, and then you open the zip, and it will give you a folder that I recommend essentially moving to your desktop, and then we will be working out of that folder. I hope that all makes sense to those of you who are following along. Also, please stop me if you like have any questions or if you like want me to slow down or anything. But anyway, so I'm going to delete that because I already have made a folder called Twitter Workshop. And yeah, this is what we're going to be working out of. So I made this file called twitterclass.r. This assumes that you already have RStudio installed because we're going to be working out of R and RStudio. So you will open this file in RStudio. So now we're going to do just a little bit of setup before we go into the whole process of working with data and downloading data. The first thing you want to do, if you're like a seasoned R person, you always kind of want to set the working directory at the beginning, unless you're working out of an R project, as Claire talked about last week. So yeah, to do that, you'll need to find the file path to the folder on your desktop. The way I always do that is I search for the terminal, and I open up my terminal, and you can essentially drag your folder to the terminal, and you can find the file path of your folder, and you can copy and paste that right here. So I've already done that. And then you can essentially set your working directory to this folder you have on your desktop. And this will make it much easier to essentially download all these files like dictionaries and data sets that I already have in this folder. So yeah, if you're working out of this folder, I recommend doing that to make things easy on you. Okay, that's our first little bit of setup. Our second little bit of setup is we have to install a bunch of packages. So I essentially have this code to install all these packages. So I recommend running this. I basically have these all installed, so it's probably going to give me warnings saying that I have all these packages installed. No, all right, don't want to restart. But anyway, so I've already have those packages installed, and those are what we will be working out of. I probably downloaded a bit too many, but yeah, so essentially the main package that you will use to download tweets with in R is called rtweet. We will also be using the package, it's called Academic Twitter. It's a new package, and it's essentially for analyzing data from the Twitter Academic API. And I'm going to be talking about the differences between these two APIs, the standard API, which is what people have been working out of for years, and the academic API, which is new. So for those of you who haven't gotten Twitter API credentials or Twitter API account, I'm going to briefly walk through the process of how you do that. So I have a link here to the Twitter API where you can apply for access to the Twitter API. So I'll just go to it. You can also just like Google how to get Twitter API credentials. And essentially what you will have to do here is you apply for a developer account. You can either apply for the standard API or the academic API. And the academic API is if you're a PhD student or a postdoc or affiliated with a university. Twitter is making it easier for you to access more data. So that's essentially what you get. Now, I've been working out of the standard API for many years, and I've just started doing stuff with the academic API. I haven't really needed a use for it so far. But the main differences are with the academic API, you are able to get tweets. Well, you're able to get what's called historical data. So that's essentially tweets dating back to the beginning of Twitter. So if you want to download tweets from 2010 to 2020, and you want to like look at a longitudinal analysis, you can do that, which is very cool. It's a bit harder to use. It's a bit harder to manage. With the standard API, you're only able to search for tweets from the past 7 to 9 days, or just get what's currently on someone's timeline. So this is what most researchers had access to before. The academic API is new, and you get those new features. So I recommend probably downloading that. There's a question in the chat. Does historical data include tweets that are now deleted? It's not supposed to, but I heard there might be a bug where you do get access to deleted tweets. So yeah, but usually not, essentially. So yeah, if there aren't any more questions about sort of this API, I'll just move forward a bit. So yeah, you'll go through this process. You'll apply for a developer account. I already have an account. When you apply for an account, you have to write a few paragraphs saying why you want Twitter data. Just say you want to use it for research, maybe talk about what you want to do with it. They'll ask you questions if you set off their alarm bells, or if they want more information. So probably don't write anything that will like scare Twitter. Just say that like, oh, I want to research politics on Twitter. I don't know. They usually approve you pretty quickly, like in a week, but they sometimes have follow-up questions for you. When you get approved by the Twitter API, you get something called API credentials, and you essentially have to authenticate your API credentials within R. So here is where I would normally do that. So where there are all these like blank quotation marks is where I would put all my API credentials, which are numbers that Twitter gives to me. So they know that it's me using the API, and they know that I'm approved. I have blanked these all out because you're supposed to keep these private. And I also have like a Twitter app that relies on these credentials. So if other people use them, it might make the app start working. So there are a number of reasons why you shouldn't like share your credentials with other people. So yeah, so kept that private here. You should replace that with your credentials if you are following along. It might take some debugging, and you might have to Google some things if you have any issues. But yeah, that's what you do for the standard API. For the academic API, you have this function called setBearer because you have something called a bearer token. I don't know why it's called that, but yeah, essentially you run this function and it takes you to like your R environment. So I will black that out because I think that shows my private credentials, but it takes you to your like R environmental variables, which means you can set, you can essentially put in your academic credentials, and you can set it as an environmental variable, which essentially means the RStudio environment remembers your Twitter credentials. So yeah, that's what you essentially do for setup once you have approval. Yeah, and again, feel free to stop me with any questions if there's confusion. Yes. Well, it depends. So if you're using an academic account, I think bearer token, where does it say access token for you?
In the PA token. So line
6 access token. That's different from the bearer token because this is for, so here is the standard API. So this is what you normally do for using the standard API. When you have the academic account, I think you just need to enter one token, which is your bearer token. So do you know which one you have, like the academic or the standard? Or... Okay, then I think if you have the academic, you should follow this. And oh, one more thing with the academic account, I had to do this last night. You have to like, once you set your bearer token, you have to restart RStudio for it to like remember that it's your bearer token. So that was like a bit of a hassle because I had to restart and I had lots of things like running. So yeah. So yeah, sometimes it takes a few like steps and bits of frustration to get it fully authenticated. But Google is always your friend when you have trouble with these coding things. Like if you have a problem, then someone else has had a problem that's similar before, and you'll figure it out. But and lots of people share their code on the internet, so there are lots of good resources. I try to share as much code as I can. So, but also other people have shared awesome code. So, yeah. So if there aren't more questions about authentication, I'll move on about how you start getting data with Twitter. So here is some functions that essentially show you how to get data from people's profiles. So this function is called get timeline, and you essentially enter the username of the account you want to get data from and the number of tweets you want to get from that account. So I want to get some tweets from my own timeline, so I'm going to run this function. And this will return 200 tweets from my timeline. And let's view what this data set looks like. So this is the data I got. This is my user ID, which Twitter assigns to me. Twitter assigns an ID to each status. Here is text of the last 200 tweets I posted on Twitter. You get info about whether it comes from the web or your phone. You get info about whether it's a retweet, how many favorites and retweets it got. You get a lot of metadata, the URLs it includes. You can scroll down. You also get, yeah, you can see how much stuff you get. You also get your bio. You get okay, that's quoted location, but you do get information about the location that I am in. It's self-reported location, so currently it says I'm in the University of Cambridge. So that's a limitation. You don't get like the exact location they sent the tweet from, but you get their self-reported locations. You can also, I'll show you this later with the search tweet function. Let's see, question. How do photos, videos show up? Let's see, for the location and the data. So if you're asking about, so you get a few photo and video data. So you get someone's profile picture. So this, you essentially get a profile. You are, it might not be this, but I think you get the URL to my profile picture, and some people essentially use algorithms on someone's profile picture to detect like their race or gender or various things about them. So here you get their profile image URL. I think you also get links to images shared in the specific tweet. You'd have to look, I think I'd have to look closely at the exact data, but I think you do get those images. Because yeah, you essentially get the URL they share, and if that is like a GIF or an image, I think you get access to that. Oh, whoops, let's see, more in the chat. I'm curious if there's a way to get a text version of an emoji, like smiley face or whatever, instead of the emoji. That's a good question. I haven't actually dealt with emojis before, so I'm not actually sure. I think people have. So see, it does show emojis here. I'm not sure. I think you'd probably have to Google if there's a specific R function about how to analyze that emoji. I usually probably just ignore those for analysis, but I think that would be an interesting way of looking at sentiment. So yeah, good question. Yeah, you get a weird text of an emoji, I think. Yeah, and there's also lots of stuff you can do in text pre-processing to remove emojis and to remove punctuation. So a lot of us just remove it, but yeah, there probably is a function in R to convert. That would be, yeah, I guess just a good thing to Google. Probably someone has made a package for that. So I'm going to run these sets of functions now. And I'm going to show you essentially how you can use this getTimeline function to build a data set. So something I did in my recently published paper with Jay and Sander about outgroup animosity going viral online is I created these data sets of Republican and Democrat-leaning news sources, as well as Republican and Democrat-leaning politicians. And I essentially just ran the getTimeline function on a bunch of news sources and a bunch of politicians. You don't have to run them one by one. You can also create a for loop. So that's what I did for the politicians, because there were a lot of things. But for just this example, I'm going to show you how you can essentially run this getTimeline function. And then I here use the rbind function, which binds these data sets together to create a larger data set. And that is the data set we're going to work out of for analysis. You can see that I'm only requesting 3,200 tweets from each profile. And that is because that is actually a limit Twitter sets for you. Twitter has like a number of API limits, which they say are designed to like not overburden their servers. Essentially, so they have various things that make it kind of hard for you to access unlimited data. You can only get data in the past week. You can only get data from the last 3,200 tweets from someone's timeline. There are ways to work around some of these limits. There are also limits to the number of times you can call a function within 15 minutes. So you can call the getTimeline function 900 times within 15 minutes, which is pretty good. But another function I'm going to talk about later called getFriends, where you get someone's Twitter network, you can only run 15 times in 15 minutes. And that makes it difficult to do some like network analysis if you want to get the Twitter networks of a lot of people, which currently I'm trying to do for some projects. You have to essentially create these loops, and you have to get your R system to like rest for 15 minutes before it calls the function again. So anyway, that's just sort of a thing you have to work around. I know some labs have worked around this by getting like multiple Twitter API credentials and then running those, but that sounds really complicated to me. But anyway, let's see, another chat. Yes, code in Python to work around the API. Yes, there are Python packages where you don't have Twitter rate limits. I have tried them before. They don't give you the data as cleanly as the Twitter API does. So I just prefer the Twitter API. But yeah, some people use those Python packages. I also just don't like Python as much as R. So yeah, and also with the historical, with the academic API, you get a bit more freedom. So I think there's less of a need to use some of the non-official packages. But that's always an option. So essentially, I just created a data set of conservative media sources by combining all of these data sets. If you weren't able to get access to the Twitter API, you can always just start here and read in this data set. See, I read because I have the data set already saved to the folder. I downloaded it last night. So you can always start there if you weren't able to do some of the things at the beginning. And we can work with some analysis there. Okay, there aren't more questions. Are there more questions? Okay, cool. I'm going to move on to the next thing, which is essentially I want to tell you about the function search tweets, which is also one of the most common functions you will use. So I wrote this last night, but I'll write it again. So I'm going to create a variable called tweets, which is a data set variable, and I'm going to run the function search tweets, which will get you tweets that have been tweeted in the past like 7 to 9 days. And you can set a query for like what kind of words you want these tweets to include. I think you can keep it blank if you just want a random sample of tweets. But if you want tweets specifically mentioning something, so let's say I want a tweet mentioning the word hashtag fake news. You can do that and you'll get a bunch of tweets with the hashtag fake news. As you see below, your Twitter queries can also take logic. So if you want tweets that say fake news or just fake, you can get either of those hashtags, tweets with either of those hashtags. Then you can request how many tweets you want. I forgot exactly what the limit is here. I think there is a limit of, it's either 3,200 or maybe 5,000 here, but I'm just gonna get 100 tweets to make it a bit simpler. If you want to include retweets, you can set this to true. I think it's automatically set to true, but you can also set it to false. I'm gonna set false. And then the last thing you can do is you can set geo coordinates. So if you want tweets from the USA, it has this neat little function where it says geocode equals lookup coordinates USA. But so yeah, it has this function for the USA, and I think it has this function for other major countries. But if you want like a very specific location, like if I wanted tweets from a specific city, you could essentially look up the latitude and longitude of that specific city, and then you set a radius. So you essentially set a circle radius around a location. It's not super precise because you only get that like specific circle, and it might take some trial and error about like what specific tweets you get from that circle. But that's basically how you get tweets from a specific location. But yeah, and also I think this whole lookup coords USA actually gets you some tweets from like Mexico and from surrounding areas, because this once again automatically like inputs the geo coordinates of the USA and then the radius around it. So it does get surrounding areas. In post-processing, you can always like look at individual self-reported location and see if it like matches a USA city. But yeah, that's essentially how you do the location. It's not super precise, but yeah. Does search tweets work with emojis, GIFs, or other visual resources? Probably if you get the specific text of the emoji or how it, I'm not sure how it processes emojis, but for GIFs, images, or URLs, you can essentially search for the URL. So for some projects, I'm interested in essentially looking at all tweets of people who have shared low quality news sources. So here are example low quality news sources from the left and right that are sort of rated by fact checkers as sometimes sharing like unreliable news. So you see, I'm essentially searching for here anything with infowars.com in the URL. And this little asterisk next to it means that like I'm interested in anything that starts with infowars.com, and then it can be like dash the specific news story. So if I just do that, it will like return to me, and right now it's downloading the data. It will return to me a data set with everything that has an infowars.com URL. So I can look at people who have shared low quality news in that specific instance. So yeah, so I'm going to view it and then Infowars. So yeah, here it shows the shortened URL, but I think somewhere else it also gives you info on the expanded URL. So you can see people have shared a lot of Infowars here. So that's, so yeah, that's great to also be able to search for the URLs. Let's see. Before I get into the academic API, which is next, I'm actually going to skip to, well, I won't skip actually. I'll go in order so it doesn't, so it's not too confusing. So the academic API has many less functions than the, well, let's say actually the package for the academic API, which is academic Twitter, has less functions than our tweet. It mainly just has the specific function, get all tweets. I think it also has one other function. You can always look up the specific functions here. Oh yeah, I mean, it has a few more, but this is the main function, which allows you to get historical data. So as you can see for this specific query, I'm interested in getting all tweets that have the word or the hashtag fake news. And you can enter a start date and an end date, which is kind of cool because you can look at tweets from, I guess, when Twitter started, like in 2007 or 2008, or maybe even before that. So here it's just getting tweets from 2020, the 1st of January to 2020, the 5th of January. Yeah, so let's run that query. Let's see if it works. I think it might have given me an error, but it seems like it worked. So let's view the tweets I got. I think did I only ask for 100 tweets? Maybe I didn't, but it only gave me 100 tweets. So yeah, here are the tweets from the academic API. For some reason, it gives you like a little bit less data. So here's the user ID, here's the Twitter text, the time it was created. As you can see, like the data they give back is a little bit messy, and I think it's because this is a new package, this is a new API, but it works. Here are the retweets. So I'm just clicking on that to sort by retweets, and yeah, and it has some geo coordinates, but all of those are NA. So I have not really worked with data from the academic Twitter API, but it seems like a cool resource. And it seems like this package is helpful. And of course, like it's quite useful for if you want data from a specific time point in recent history, or if you want longitudinal data. So if you want to look at how things in 2010 compared to 2020, you can do that now. And you weren't able to do that until quite recently. Yeah, that's pretty cool.
I have a quick question. I missed that because earlier you said you can't go back in time.
You can't with the standard API and the RTweet package.
Oh, okay.
So yeah, the academic API and academic Twitter allows you to get historical data, which is the main benefit of it. But it's kind of harder to do it. There's some things that you have to play around with. I think it's also bad with getting like large data sets. It says it's giving me this warning about specifying a data path. And I think it's because like when you get like large amounts of data, you have to do some special things to combine it, which I have not yet figured out how to do. But yeah, theoretically, it should be possible, yeah, to now get historical data using that package. So yeah, it depends on what you want to do. If you want the historical data, or if you want just the recent data. Some other cool functions with RTweet are you can get someone's Twitter network, which I've been using this function a lot because I'm working on a project where I'm essentially looking at the Twitter networks of people who are anti-vax, and I'm looking at like who they follow on Twitter, which has been sort of fun. They follow a lot of like right-wing or conspiracy theorists, which isn't hugely surprising, but yeah, I've been using this a lot for that project. So to run this function, this is called get friends. So I'm going to get my friends on Twitter, and friends are people I follow. So network get friends. Now let's see what this looks like. So it gives me my username and a bunch of user IDs. Now user IDs aren't super helpful. You probably want their screen names. So if you want to do that, you can run this function, which is called lookup users. And you can essentially look up the profile information of all these people. So it's currently looking up the profile information of like 2,000 people. So that's why it took some time. You can get their screen names. You can get their, this is their bio text. So yeah, lookup users quite useful. And you will have to, when using the Twitter API, switch from like user IDs to screen names a bit. There's also this function get followers, so you can get the people who follow me. And once again, you get sort of just a list of user IDs, which you will need to deal with lookup users. If you want to know like what your Twitter API rate limit is at, you can run this function rate limit. So this shows that I have 14 calls of the get friends function left in the next 13 minutes. So I can only call this function like 14 more times, and then it will start giving me an error if I call that function anymore. So this is useful. I mean, you can also put other functions in here, like look up users, see how many times I can use that. I can use it 76 more times. So yeah, those are like the main functions for getting data from the Twitter API. Let's see, I have a question. Side question, perhaps. You have noticed many fake accounts in your data. Do you remove accounts from your data that have 0, very low follower count, etc.? So yeah, there are a few things people do to deal with this. There are algorithms and R packages called, like, one's called botometer, one's called bot or not. People have created algorithms that are supposed to tell if someone's a bot. So something some researchers will do is they'll essentially run this algorithm on specific users, and they'll like exclude people who are likely to be bots. These algorithms are sometimes flawed, and that, I mean, one of the algorithms said that I have like a slight chance of being a bot, and I think it's because like I retweet more than I actually post tweets myself. So sometimes these can lead to false positives, but people do a few things to try to deal with bots, but it's not perfect. And I personally don't use those algorithms much because, yeah, sometimes I just look at raw engagement data, and it's sometimes just hard to differentiate with much certainty whether it's fake engagement or real engagement. Sometimes, yeah, I think sometimes the bot problem on Twitter is overstated. There are definitely bots or like hyper partisan accounts, but I don't know how, well, it's actually hard to say how tremendously common there are. But yeah, depending on how interested you are, there are ways to deal with that using some of those packages. Cool. So now I'm going to move forward to analyzing some of this Twitter data that we have collected. I've gone over some of the basic functions for getting Twitter data. So yeah, now, as a reminder, we're working with this data set, which is called dataset, helpfully. And it has 16,000 tweets, and it has Republican media tweets. So here's some just like basic things you can do to look at an initial pass at your data. So this uses a lot of functions from the package dplyr, which is very helpful. So what I'm going to do is I'm just going to look at the most popular tweets in the data set. So I'm going to call dplyr select and just select the variables I want to show, which is the text, the retweet count, and the screen name. And then I'm going to arrange them using this line of code by the most retweeted tweets in the data set. So let's just run that. And then we're going to view most popular. Here we can see the most retweeted tweets in the data set. So this should just sort of descriptively give you a good chance of what's going viral. It's a lot of Daily Caller and Breitbart News, and lots of Breitbart News seems to be quite popular. New York Post has a lot of not as popular tweets. So yeah. Now, let's say I'm not like just interested in the specific tweets, but I'm interested in the specific words associated with the most virality online. So this uses some text analysis, which Claire has sort of talked about this in previous tutorials before. But I'm going to run this function called unnest tokens, which will essentially like just look at all the specific words in my data set. So, and create something called n-grams, and which is a little bit of, I guess, like jargon from some of the text analysis stuff. So I'm going to view these words and see this just split my data by like each individual word. So that's like 300,000 words. Now, something cool you can do with this is then you can look at the words associated with the most virality online. So I'm going to run this next line of code, which will essentially, this once again uses functions from our package dplyr. It will group by each individual word here. So we'll like look at all the words used together. And then here, it will look at the mean retweet count associated with that particular word in a tweet. Here, it will filter out and it will only look at words used at least 10 times in the data set. So we don't just look at really rare words. And here it will arrange these words by the most retweets that they have received. So I'm going to run this little function here. Now that we've run it, let's view. So yeah, now we can see the most retweeted words. And the word email is popular, as is patriots, as is Carlson, communism, aliens, Tucker, whistleblower, etc. And now we didn't run this on a super big data set, so there's some like randomness, but if you run this on, you see words like immigrants, if you see words like this, you might be able to sort of get a sense of like, oh, okay, what topics are popular amongst conservatives here? What's this being associated with the most retweets in conservative media? And that might help inform some of your hypotheses and just be like interesting descriptively to look at as well. Okay, now that we've looked at the most retweeted words, let's say we have some specific hypotheses about like the kinds of words being used in these tweets. So I have included in my Twitter workshop folder a list of dictionaries that I and other researchers have used for analyses. So one dictionary is created by Billy Brady and Jay Von Bovel, which is just moral emotional words. So words that have moral and emotional content. And then also I have a dictionary of polarizing words, also from a paper that Jay and some of his collaborators were on. And then I have also dictionaries of words referring to the most famous Democrats, the most famous Republicans, just a general list of Democratic Congresspeople, a list of Republican Congresspeople, and then also words that just refer to conservative or liberal identities more broadly. So if you want to read in these dictionaries, and essentially what I'm going to do with these dictionaries is something similar to what we've done in our papers. And we're going to look at whether using words in these dictionaries predicts retweets. So if you want to read in these dictionaries, you can just run these functions. You can see it reads in all the items. So you're just reading in these text files. You can also enter in a dictionary this way. You can just create a list of words directly in R if you want to just kind of go quick and dirty with some of your hypotheses here. And by the way, this is using the R package Quantata, which is like a really useful package for text analysis. It's probably the main like R package that text analysis people use. It's quite useful. Then I'm going to create an object, a dictionary object called dictionary, which is essentially, yeah, for my analysis, I have to create a dictionary using these files I've read in. And we can look at what that looks like. So here it shows that I have this dictionary object that has all these sub-dictionaries that refer to specific categories. And I'm going to use these dictionaries to analyze my tweets. So here are the steps for looking at how often people use words from these dictionaries in tweets. First, and this involves like a little bit of jargon that might be like confusing, but yeah, don't be, yeah, I guess overwhelmed by this. It's just text analysis jargon. So next you have to create something called a corpus of the data set. I don't know exactly why it's called a corpus or what it refers to, but it's just basically this object of like texts, and in our case is specific tweets that you prepare for analysis. Then you have to turn the corpus object into a tokens object. And here, Quantata provides you with some functions that allow you to do some pre-processing, removing punctuation, removing URLs, removing numbers, etc. You can do more pre-processing. You can remove emojis if you want. You can remove other things. Here, you can also remove stop words, which is like removing words like a and the. Although sometimes these can be interesting for analysis. So, but yeah, I'm just going to do that basic removing of those specific things. This took just a second. Oh, it's still running. Okay, I think the function should be done running very soon. But if you have any questions while this function runs, please let me know. Yeah, it looks like there's a question. These tweets are all within a certain date, right? Yeah, well, actually, it depends. So I was using the function get timeline to get these tweets. So if someone has not tweeted in like 4 years, it theoretically could show tweets from like 4 years ago if those are still within the most recent 3,200 tweets from someone's timeline. So it's a bit complicated, but you can also just like run analysis after you've collected the tweets to make sure they fall within a certain date window if you're interested in that. So yeah. Oh, I think it's running the function twice. Okay, it finished. Okay, it finished it twice. Then another piece of jargon, you then turn this into something called a document feature matrix, where you run your dictionary on this tokens object. So actually, let me show you what the tokens object looks like. So here, it split this into a bunch of little individual words you can use for analysis. You don't really need to know a lot of the details of what's going on under the hood. You can just kind of run this code yourself, but just to explain everything. So then you create a document feature matrix, which is essentially, it looks like this. So as you can see, it shows each individual text, and it shows a count of how many times words from each dictionary, the moral emotional dictionary, the polarization dictionary, and the Republican and Democrat dictionary were used in each tweet. So for tweet number 3, it had 2 polarizing words, 1 word about Republicans and 1 word about Democrats. Now you need to convert this object back to a data frame, because R likes data frames. You can combine this document feature matrix with our original data frame of tweets. Yeah, and then you get a combined data set that shows you all the tweets with all its information, with also the counts of how many times it uses words from each dictionary. And then you can use this for some cool analysis. So what we're going to do is we're going to predict essentially whether the use of a specific word in a tweet predicts retweets. So we're just going to run some basic like multiple regression models for this. You can run other models if you wish, but here's one approach. It's quite similar to the approach we used in our recent paper, except we used it on bigger data sets. So since we're working with a smaller data set, there will be more noise. The results probably won't be as clean. I recommend with Twitter or social media data, your data set should be probably like like 100,000 or multiple 100,000s, just because it can be so noisy that like, yeah, you want some like big data for your results not to be super variable. And as Jay's recent like moral contagion meta-analysis showed, some of the smaller data sets had more like variable effects. So yeah, that kind of happens because big data is messy. But anyway, so to run these models, I'm going to create these 2 binary variables here, which are essentially just control variables that are either will be just like true or false binary variables to indicate whether a post has media or has a URL, because these are known to influence retweet rate. So we want to control for these. Then next, I want to show you something about retweet count. So we're going to look at the combined data set, and we're going to look at how the retweet counts are distributed. And as you can see, they're over dispersed. So they all kind of cluster around 0, and then some are really viral. So you want to do something about this. Either you can do some sort of like negative binomial regression, or you can just try to log transform the retweets and see what happens. So let's see what happens there. So when we log transform them, and we have something that's looking more like a normal distribution when we log transform the retweet count. So let's just say, yeah, let's just go ahead and analyze our data on the log transformed retweets. And let's see what happens. So this is a general linear model. So this is a multiple regression model. And we're going to predict retweet counts by how many times each tweet uses a word referring to a Democrat, a word referring to a Republican, a moral emotional word, a polarizing word, and then we're going to enter these control variables, whether a tweet has media, whether it has a URL, the follower count of the account, and this is probably going to be most predictive of retweets. So you really want to control for this because big accounts will get more retweets, small accounts will get less. We're also going to control for whether the tweet itself is a retweet. You can also eliminate retweets from your data set. There are lots of choices you can make here. So yeah, so let's just run this specific linear model. So this is from the package JT tools, which just is sort of a helper package for multiple regression models. I'm going to exponentiate the coefficient, which makes the coefficient more interpretable. So you can like interpret the coefficient as a percent increase. You'll see what I mean when I show you this. But yeah, so here are results. So again, this is a small data set, so let's not read too much into this. But essentially, first of all, you'll notice a lot of the p-values are significant. So that happens in big data, so it's probably better to pay attention to effect sizes. What you can see is words referring to Democrats here seemed highly predictive of virality. So we see the biggest coefficient with words referring to Democrats. That's consistent with my last paper that talking about the outgroup gets you more retweets if you're, because we were only looking at conservatives. Because the effect size was sort of exponentiated here, you can interpret this as like each additional word referring to a Democrat was associated with a 98% increase in retweets. Yeah, it's sort of helpful to exponentiate your coefficients so they're interpretable. You can also see Republican words were associated with an increase in retweets. No effect of moral emotional words, but again, this was a small data set, so I won't read into any of these coefficients. And then you also see an effect of polarizing language getting more retweets. Interestingly, whether the tweet has media or URL was associated with less retweets. I think the reason the followers count thing is one was because like, I don't know, I think it's like because this is like such a big coefficient. I'm not really sure why we have that result there. And then, yeah, retweets got less retweets.
One increase in followers isn't a lot of increases in followers. Right?
Oh, okay.
Like
Yeah, you're probably right.
Yeah.
But yeah, but good to include as a control variable anyway. But yeah, we're essentially going to ignore these control variables because we're just interested in controlling for them. And we're going to look at those variables. And then you have the confidence intervals. So this is stuff that you can report. There are also, I think also sort of at the end of this, I gave you some resources on how to plot these effect sizes. So if you want to plot multiple regression models, I recommend this great package called DW plot or like .whisker plot. So here you can sort of see all the coefficients. You can play with these plots to make them a lot prettier as you do and R, where it takes you forever to like play with plots to make them prettier. But yeah, this is the package I use for my paper, and then I just played with them a lot and I made them prettier. And then that's yeah, like in these were sort of the like boiled down methods of what I did. I just basically did it on a larger scale, and I did it with more, variables and data sets. But yeah, so anyway, this should give you like a good summary of how to like download and analyze tweets. These are a lot of functions I've used in my data. And this, if you want to work with Twitter data, hopefully this code is like also a useful resource for you in the future. So that's most of what I have for Twitter data. I did want to give you like a brief summary on like how to get data from Facebook using Crowdtangle, and that will be like really quick. I just kind of want to go through what Crowdtangle is as a resource and how it could be useful for you. Before I move on, are there any questions about what I have covered here or about Twitter data in general? Also, I want to make sure my computer is charging so it doesn't run out of battery. Oh, wait, I think I have to plug it into this thing. Okay, it's working now. So any questions? Okay, cool. Well, I'm going to give you a quick summary on Crowdtangle. We can also have more questions at the end if you just have general questions about social media data. Crowdtangle is a super, super cool resource for getting Facebook data. It's very popular like amongst journalists. It's you'll see a lot of like articles being written using Crowdtangle data. It's one of the only ways you can access Facebook data. There are also controversies about it because Facebook is apparently mad that people are publishing bad results using Crowdtangle. So there's drama over like Facebook is rumored to be cutting off access to it in the future. I don't know if that's going to happen, but like I recommend you maybe start using it soon, just in case Facebook doesn't let you use it in the future. But Crowdtangle is something you have to apply for access for, like the Twitter API. I was approved pretty quickly for access. I just said like, yeah, I wanted to use it to analyze political tweets and stuff, and they approved it. And I said I was a PhD student. So you have to apply for it. But yeah, I mean, I would just Google like apply Crowdtangle academic access, and you should get to, this page about Crowdtangle for academics and researchers, and then you should be able to apply here. And once you apply, you have access to the Crowdtangle dashboard, which is a super cool resource. Another thing I can do is if you're collaborating with me on a project, I can add you as a collaborator to my dashboard, and you can just sort of have access to my dashboard. So that's one way to get around that. But I would also recommend applying yourself because it's not that hard. You can get access pretty quickly. So here's what Crowdtangle looks like. So yeah, it has a few features. One feature that is cool is, well, first of all, you can look at the most popular posts across all of Facebook, which you can see is right now is Cristiano Ronaldo and Bruno Mars and Christiana, sorry, and David Beckham. People love soccer. Yeah, I don't know anything about soccer or sports, but anyway, this caused controversy because for a while, the most popular posts on Crowdtangle were just literally posts of like Ben Shapiro and very conservative media, which Facebook, and this was reported on. Facebook didn't like this. I think Facebook might have like changed its algorithm to make it not like that because journalists would like sort of trash on them. So yeah, one thing a lot of journalists have been paying attention to is like the top posts on Facebook. So that's one thing you can do. You can also, using Crowdtangle, and this is the main way I access data, is you can create lists of either pages of people or groups of people. Now with Crowdtangle, you only have access to public pages. So you can only get like the pages of politicians or news media accounts. So you can either create a list yourself. So I'm going to create a list of politicians here, and you can essentially search for, so like if I want to add Biden's page to this list, I'll search for Biden, it will load. Crowdtangle sometimes takes a very long time to load, and then I'll add Biden. And let's say I also want to add Jill Biden and riding with Biden. Like you can add you can add a bunch of pages to your lists. And yeah, so that's an example of how you create lists. But you can also, Crowdtangle has created some lists for you. So and I've created some lists as well. So if I want to just look at a list of Democrat-leaning media sources, I created this list before of Democrat-leaning media sources. And then you can essentially you can download data from these lists of pages you have created. So the way you do this is you go to this page, you say historical data. You can get data by lists here. And then I want to download the list of Democrats. I want to get all posts. I want to get the most recent posts. And you can get it from either the last 7 days, last 12 months, or all time. So let's say I want the last 7 days, and then you click Fetch History, and it should be emailing you a CSV of that data. And now I'm going to show you a bit what that data looks like because I downloaded it earlier. So I have this file called Crowdtangle sample.csv, and I'm going to read that into R right here. And I'm going to show you what Crowdtangle data looks like. So this data is actually pretty cool, and I think it gives you a lot of benefits over Twitter data. Even though Facebook should be sharing more data and it's very limited, there's some things about Facebook data that give you a lot more options beyond just Twitter data. So here you have the names of all the, oh, I think this data I downloaded earlier was probably a list of Congress members, not a list of media accounts. So you can see these are all government officials. You can see the description of their page, when their page was created, how many followers they have, the type of media they have. And I think this is where the Facebook data gets cool. You can get the total interactions that posts received on that page. And then you can also get the number of comments, the number of shares, love reactions, wow reactions, haha, sad, angry, care, etc. And you can essentially do the exact same analysis that I showed you earlier with retweets, but you can see how specific words predict angry reactions versus how specific words predict love reactions versus how they predict share reactions, etc. And you'll get probably like a much broader sense of like the kind of engagement these posts are generating and the kind of sentiment that they're generating from their Facebook reactions. So I'll show you how I use some of this data. If you've seen my recent paper, this isn't very new to you, but like I essentially use this data to create figures where I looked at how certain words predicted different reactions. So instead of just looking at retweets, I looked at how in-group and out-group words predicted heart reactions versus haha reactions versus wow reactions versus angry reactions. And as you can see, this sort of gives you a more nuanced sense of like what kind of engagement things are generating. So you can see out-group words are generating a lot of angry reactions and haha reactions, whereas in-group words are generating more love and like reactions. So yeah, kind of this data gives you a broader sense of the sentiment. And I think there are lots of possibilities with Crowdtangle data because it's a bit of a newer resource. And it gives you this sort of sentiment type thing, which, by the way, in my experience, sentiment analysis, just text-based sentiment analysis is very imprecise, whereas like actually getting the reaction the emotional reaction someone is getting from a post with angry reactions, etc. I think it tells you much more about like what someone is feeling than just looking at sentiment analysis alone. So the data structure is super similar to the data structure that Twitter gives you, but you just have all these extra reactions, which I think are cool and give you new possibilities. And I have some code for analyzing this data, but it's basically exactly the same as the Twitter code. So I'm not going to go through it, but you guys can, yeah, go through that on your own. But yeah, that should be everything. I think I have maybe, yeah, some extra other code if you guys want to go through that on your own. But yeah, just let me know if you have questions about anything I've discussed or about social media data in general. Or yeah.